Hi, in this presentation, we will introduce our paper titled FALCON, False Negative Aware Learning of Contrastive Negatives in Vision Language Alignment. The goal of vision language pretraining is to learn cross-modal representations from large-scale image-text pair. The inclusion of hard negatives, those that are semantically similar to the anchor sample, has been shown to be crucial for successful VLP. Although effective, these hard negative sampling strategies exhibit a critical limitation, as the selection criterion favors negatives with higher semantic similarity to the anchor. The likelihood of mistakenly identifying true positives as negatives, which is false negatives, correspondingly increases. Incorporating such false negatives into contrast learning can substantially degrade representation quality by compelling the model to separate embeddings that should ideally remain close within the shared embedding space. To retrieve hard negatives, prior works have commonly adopted cosine similarity of embeddings as a selection criterion. Selecting images or text with high similarity to the anchor. It is widely acknowledged that there exists an optimal similarity range that facilitates effective hard negative mining while minimizing the risk of false negative inclusion. To address this challenge, prior works have leveraged strong pre-trained models, for example, BLIP with 129 million parameters, to detect potential false negatives in image-text pairs. However, pre-trained models struggle to generalize in complex scenarios due to limited prior exposure, often assigning low scores even to symmetrically aligned pairs, just like in this figure. Consequently, applying a fixed threshold would be either overly conservative for simple pairs or insufficient to eliminate false negatives in complex pairs. This is an overview of FALCON. Starting from a randomly selected anchor, the scheduler pi theta predicts hardness quantile values to iteratively sample additional candidates, forming a mini batch indexed at I. This batch is used to update the VLP model. The reduction in masked language modeling loss serves as a proxy for enhanced cross-modal alignment, providing a learning signal that guides FALCON toward constructing more informative mini batches in subsequent training steps.
FALCON adapts its negative sampling strategy based on the similarity distribution over samples. When the scheduler determines that an anchor would benefit for more informative and challenging negatives under the current state of the VLP model, it samples a quantile value closer to 1, thereby selecting harder negatives. Conversely, when the potential risk of sampling false negative is high, the scheduler assigns a lower quantile value, favoring negatives that are semantically dissimilar and thus less likely to overlap with true positives. FALCON achieves significantly better performance compared to heuristic negative mining methods. Notably, hard negative sampling approaches that do not explicitly address false negatives suffer from degraded performance, as false negatives introduce conflicting supervision signals. Meanwhile, methods that attempt to mitigate false negatives by leveraging pre-trained models are also face inherent limitations. We believe that these approaches, which rely on fixed similarity threshold or static filters derived from pre-trained representations, are insufficient to capture the dynamic nature of optimal similarity through training. Figure on the left shows that FALCON adaptively adjusts its strategy to reflect the temporally evolving optimal similarity range, enabling more effective hard negative selection. Early in training, FALCON predominantly samples high quantile negatives to construct challenging mini batches that accelerate representation learning. As the embedding space gradually matures, the likelihood of encountering false negatives within the search space increases. Consequently, FALCON adaptively lowers its target quantile to mitigate the adverse impact of these hard negatives. Although FALCON requires additionally forward passes and updates for the scheduler network, it achieves better performance related to wall clock time, highlighting the effectiveness and importance of dynamically balancing the trade-off between hard and false negatives during vision language pre-training. Thank you for listening.